Hello everybody, my name is Daniel. Today I'm going to be showing you the current state of my multiplayer game engine now that I've worked on it for an additional week. And what better way than to show you a actual multiplayer game that I made. So this is a two-player game where you shoot each other. So pretty standard as far as multiplayer games go. So I've started up the server and here I'm opening two clients. Now, what you'll notice is that we're not in the game right away. So one of the things I added this week is support for basically single player scenes. So when you start the client, this is the menu screen. Not much going on in terms of menu screens, but let's press enter to join. So on the right here, this client has joined the server. We can see some debug output from the server going on. And well, it looks like we're in the lobby and we're waiting for another player. So the other player is going to join and we're into the game right away. And so you can see in this game, you can move around, you can shoot lasers, and I can shoot this guy. It's kind of hard to demo a two-player game with one computer, but you can see as I'm shooting, the health counter is going down here. Now, I did not implement this game completely, as you can see, health -4, but yeah, I mean, I just think this is a good example of what my multiplayer game engine can do. You can see I move my mouse around, the ship follows it, it quickly updates on the other side. The movement's pretty smooth, shooting is pretty smooth. You can see that there are some differences, like if you're watching the right carefully, you can see that the bullet disappears at a slightly different distance. It's kind of due to synchronization problems, and when like the destroy bullet message comes to the server relative to like where it's moving. So it's not perfect, but I think this is a pretty cool feature to have in my engine. And so with the demo completed, well, I guess one other thing, you can see that when you leave, you go back to the lobby, so that's kind of cool. But with the demo completed, I just wanted to go over some of the the roadmap that I had created previously. So this past week, I think I finished up starting with these. So functional changing of scenes at runtime, you kind of saw that. We start in the lobby scene and then we go to the actual game scene once there are enough players. Player and join leave API. So I can actually show you what the API looks like. So here in the lobby manager component, which actually runs on the server, which is kind of interesting. So let's take a look at the lobby scene. In the lobby scene, we have the lobby manager running on the server. And you can see it's kind of self-explanatory. We register a event handler for when a client joins, and when it leaves, we can check out who's joined, and if there are enough players to join, let's go to the battle. And you can see in this lobby scene, we also have the lobby status, which runs on the client. So if we quickly look at lobby status is just checking out how many players are connected and drawing the waiting for players, number connected out of lobby size every frame. So it's kind of a good example of the split architecture we have going on, where there's logic running on the server and there's logic running on the client. In terms of the actual battle, let's take a look at the battle. So we have just a battle manager, which runs on the server, and we have the arena. So I didn't actually demo this in the game. Maybe I can quickly show you what the arena does. You might have noticed it with the bullets, but the arena just prevents you. I'm trying to go up, I can't go up. I'm trying to go right, and there's a invisible wall here. That's what the arena is. But the battle manager, let's quickly take a look at this. You can see that on the start, we get a reference to this battle state component. that's actually old. Ignore that. The battle manager, we check out however many players are joined, and for each joined player, we create a battleship, and we position it and set the starting health. Then we also set up some event handlers, so if somebody leaves or joins during the game, if you join, you get assigned the spectator kind of role, and if you leave, the game stops. But yeah, then the battleship is kind of the heart of everything. So the battleship, we're taking a look at the actor template. You can see it has the transform, which is an interpolated transform. You'll note that it's server replicated, which means that its state is replicated between servers and clients. So when you move to the left, move to the right, that gets sent to the server. Same thing with health. So when a bullet hits you and the health decrements, that gets sent to all the other clients. We have keyboard controls, which you should only be able to control your actor with the keyboard if you're the owner. So this is one of the things I implemented this week was owner support. So each actor has a quote-unquote owner client. And you'll note in the battle manager, when we instantiate the battleship, we're actually calling a function called instantiate owned, and we can pass the client ID to say, okay, client 1 owns this specific ship, client 2 owns this specific ship. And so, you're not fighting over the controls with the ship that isn't yours. Same thing with point towards mouse component. We have the arena trap component, which just makes sure your ship can't fly out of the arena. We have the shoot component, which shoots laser bullets. And sprite renderer runs on the client. Health UI, which draws the health in the top left corner, only runs on the owner. So you could customize this to run on every client and then just draw a health bar somewhere for each player. But yeah, and then let me just quickly show you what player health looks like. So you could see an example of what a server replicated component is. So pretty simple component as far as components go. There's no update or start logic. All it has is a way to serialize it to the network and read it from the network. So you can see write int self.health and then self.health equals read int. So pretty simple in that sense. And let's go back to the roadmap. So I covered the player join leave API, synchronized event API. So interestingly, the player join leave API, even though it looks like you're calling multiplayer.onClientJoin, it's actually using the event API in the background. And so what I ended up doing was sending event publishes to other clients in the server if you want. So that allows a lot of custom logic in your multiplayer game. I mentioned client ownership of actors. One small thing I did was you can now configure in the game where to connect to, where does the server live. So you can see in the client joiner, we're connecting to localhost port 7462. So you could, put your host here and your port here and have everything work. Synchronize actor destroy. You'll note that in the game, the bullets, when they hit the ship or they hit the edge of the arena, they're destroyed, and they get destroyed for everybody, not just the client in charge of moving the bullets and checking if they're out of bounds or hit. So that was one thing I implemented. And single player scenes, I showed you the very simplistic menu, and I built the 1v1 shooter. And I didn't get around to building the chat game, nor did I get around to unbreaking physics. But yeah, so that's been my progress this week, and I think I'm pretty happy with how my game engine works. So yeah, thank you for watching.